Okay, in this part of the video, I'm going to go over how you determine if a function table is linear, exponential, or quadratic. So in all of these, your x values have to be consecutive. That means there's no gaps and they're going from one integer to the next. So here we have, they're in order of least to greatest. Now I can just focus on the output pattern. So the first thing I'm going to check for is a first difference. So how I'm getting from one output to the next. So from 14 to 10, I'm going down 4. And from 10 to 6, I'm going down 4. And 6 to 2, and 2 to negative 2, and so forth. So you can see that there is a first difference that is constant. So this tells me that this is a linear function. And also the negative 4 would be your slope value. So if you had to write the equation, negative 4 would be part of your equation. It would be the m in y equals mx plus b. In this second one, I can kind of see just real easily that these are being doubled each time. And anytime you are multiplying to get from term to term or output to output, we know it's going to be an exponential. So this is being multiplied by 2. It's doubling every time to get from output to output. So this has a constant ratio. So this is going to be exponential. And the 2 part would be the b value of your equation. So again, that will help you write an exponential function. The third one, I can see it's not being multiplied. So we are going to find a first difference. So here from 21 to 12, that is going down by 9. And 12 to 5 is going down by 7. And then we're going down 5, down 3, down 1, and then up 1. Okay, so we know it's not linear because it doesn't have a constant rate of change. So now let's check for, so that's the first difference. So now let's check to see if there is a second difference. So from negative 9 up to negative 7, that's plus 2. From negative 7 to negative 5 is plus 2. And I can see that there is a pattern of going up 2 on my second difference. So this tells me it is quadratic. And this value, the second difference, helps me get the a part in standard form of a quadratic equation. I would take my second difference of 2 and divide it by 2, and my a value would be 1. Okay, let's go to our fourth one. From negative 16 to negative 13, I can tell that it's kind of going down. Up by 3. So I'm going plus 3, and I'm going to check all the way down. And then from negative 1 to positive 2, it's an increase of 3. So this is linear, and this would be my slope in y equals mx plus b. So when we're writing our functions, we're going to have the linear function, y equals mx plus b. So in this case, my m would be 3. So that's a linear function. Of course, there's other versions, but this is the one that we use most often. And then we have our exponential function, and the most basic is f of x equals ab to the x. And then with our quadratic, of course, we have 3 different versions of quadratic. But again, we mainly use the standard form. So just as a reminder, these are the 3 basic equations that we'll use when we're writing different ones. Now, in this unit, we are focused on quadratic, but we will get to our very last unit of the year. We'll be comparing all 3 functions, but we're going to focus on quadratic for this unit. Okay, the next one, we're going from negative 2 to negative 8. So that is going, doesn't look like it's been multiplied by anything. So immediately just find the first difference. So that's going down 6, and then I'm going down 2, and then back up 2, and then I'm going up 6. So from negative 6 to negative 2, that is an increase of 4. From negative 2 to 2 is an increase of 4, and from 2 to 6 is increase of fourth. So that lets me know, since it has a second difference that's constant, this means this function table is quadratic. So this would be my A value. You take your second difference and you have to divide it by 2. So my A value would be 2. Okay, on the last one, we can kind of see, if you just look ahead, it looks as though, yep, we're just multiplying by 3 to get from term to term. So that has a constant ratio. And this would, so this is exponential. And this would be the B term of my equation. It would be the multiplier.